Hey guys, Mr. Tegan here. This is another video. This one should help you out with 9H3 or the overall topic of this is testing for outliers and doing outlier box plots on your graphics calculator. So previously in the statistics topic, we've talked about the fact that outliers are any data values that are significantly different or significantly separated from the main body of the data. But what do you mean by significantly? There is a commonly used mathematical method for finding outliers, and that involves finding the upper and lower boundaries. Anything outside of these will be classed as outliers. So your upper boundary using this method is going to be the upper quartile, so Q3, and then add onto that 1.5 times whatever the interquartile range of the data is. Okay, so your upper boundary for outliers is going to be 1.5 times whatever the interquartile range is, larger than the upper quartile. Any data values that are larger than that boundary will be an outlier. And then your lower outlier boundary is going to be the lower quartile minus 1.5 times by the interquartile range. So any values that are smaller than that lower boundary will be outliers as well. So as a quick example, test the following data for outliers and construct a box plot for the data here. So let's do this for real. Let's do it live, okay? Select the calculator, clear. So first things first, statistics always involve a data set. So you need to enter that data set, 3, 7, 8, 8, 5, 9, 10, 12, 14, 7, 1, 3, 8, 16, 8, 6, 9, 10, 13, 7. Hopefully that's 20 bits of data. Looks like it, yes. So first thing I'd want to do is order it. If you're doing this by hand, you would have to order it so that you can write it out nicely in order. And this first step would help you do that. Okay, so the ordered data set is 1, 3, 3, 5, 6, 7, 7. Alright, 7, 8, 8, 8, 8. 4 8s. 2 9s. 2 10s. 1 12, 1 13, 1 14, 1 16. Hopefully that's 20. Yeah, it's the same one. Okay, so ordered data set is there. Now I could do this by hand and work out where the mean the 5-number summary is, because you need to work out what the interquartile range is to work out what the boundaries are. But I can use a calculator to do that. So go stat, calc, 1 bar stats. My data is in list 1. Alright, so all the data I need is here. Min is 1, Q1 is 6.5, median is 8, Q3 is 10, max is 16. But I'm only trying to work out what the interquartile range is, and I also need those quartiles. So IQR is going to be Q3 minus Q1 is 10 minus 6.5. That's going to be 3.5. Alright, so now I can work out what the upper outlier boundary is going to be the upper quartile, which was 10, plus 1.5 times by the interquartile, which was 3.5. So that's going to be 10. Using BEDMAS, I need to work out what 1.5 times by 3.5 is. It's going to be 5.25. So the upper outlier boundary is going to be 15.25. Just double check that there. I don't trust myself. Yeah, 5.25. Good. Upper outlier boundary is going to be like that. Lower outlier boundary is going to be the lower quartile, which was 6.5 minus 1.5 times by 3.5 is going to be 6.5 minus 5.25, and that is going to be 1.25, I believe. 6.5 minus 5.25. Yeah, 1.25. So anything larger than 15.25 is going to be an outlier. Anything larger than 15.25 is an outlier. Therefore, which of these is an outlier? 16. That's an outlier because it's more than 15.25. 16 is anything smaller than 1.25 is an outlier. Therefore, was there anything smaller than 1.25? Yes, 1 is an outlier. According to this calculation, this method. Okay? So that is how you test for. We've tested the data for outliers. We sorted it. We worked out what the interquartile range was. We worked out what the outlier boundaries were. And we determined that 16 was outside the boundary, so it was an outlier. And also 1 was outside the boundary, so it was an outlier too. Now, I just wanted to show you an application of that rule drawing the box plots, because you conveniently have a method of doing that on the graphics calculator. And hopefully it comes up with the same conclusion as us, that 16 and 1 are both outliers. So how do you draw a box plot with outliers on it? I briefly talked about that in the box plot video, but if you go second stat plot, turn the plot on, and this time select this icon, which is the box plot with dots on it, which indicate outliers. Set the X list to L1. You can have the mark whatever you want, doesn't matter. Press graph, and now I want to zoom so I can actually see my statistics. And there you go. The calculator has used the same formula for outlier boundaries as us. It's the 1.5 times by the interquartile range above and below. And it's identified 2 outliers, and hopefully they are both, they are 1 and 16 like we said. So if you press trace, scroll over to there, yes. So that outlier dot indicates 1. This outlier dot indicates 16. So we have, in another way, indicated box plots. Outliers using a box plot using the graphics calculator. So if I could take a screenshot of this, and I could import it into the file as an example. And so I'm just putting this example in here so that you are aware, when you are drawing box plots with outliers by hand, the box plot ends, the whiskers end at the last values that are not outliers. The outliers must be separated as dots or little stars or something. They're on the scale, they're separated. All right, the whiskers only extend to, what did we identify was the last bit of data that was legit? Well, our data now, because we've determined those 2 are outliers, our data only extends from 3 up to 14. So the maximum, the end whisker is 14, and the minimum end whisker is 3. So you can see that if you were drawing this by hand, your box plot whiskers wouldn't extend up to here and finish with a line, extend up to here and finish with a line. It would extend to the last non-outlier bit of data on the low end, last non-outlier bit of data on the high end, and then you draw the outliers separately. Okay, then the rest of the box plot remains the same. So hopefully that helps you out with drawing box plots with outliers. marked on them, and also identifying outlier boundaries and identifying and scanning through data to identify what are outliers. And see you on the next video.